Hey guys, myself I'm Shekhar. I'm an ML engineer with experience in deep learning and ML ops. Today I'll be helping you out with setting up your Triton server and serving your visual language model on it. So let's just get started with it. So in this video we'll be basically doing two steps. One is setting up your Triton server and another will be setting up your VLM. So there are two ways to set up your Triton server by building it from source, and another one is building it from or like otherwise using a Triton Docker image. So building it from source could be exhaustive by installing many tools that you don't want on your system and building everything from scratch, creating binary files and everything. It will take a lot of time. Whereas a Docker image would contain relevant tools and the binaries will already be built inside the image itself. So let's get started with a Docker file. Mainly, we'll be creating another image where we will have a Docker image, Triton's Docker Inference Docker image, as well as other requirements that's needed to set up a VLM. So for this, I'll just create a Docker file. Moving on, let's just copy this, which is we'll find our NVIDIA Triton server over here. So there are many versions of variations of Triton's images. The one we'll be using is a PyTorch Python version that has support for Python and PyTorch and Python backends. I'll just get into the tags and here it is. So we are back to our image, Docker image. I'll just import from here our image. I'll set up my working directory to workspace and I'll just copy this. Let's come up with that. I'm sorry. Yeah, this one. So these are the dependencies that we need to install as per, since we'll be also installing flash attention so that our VLM could use it. We are installing other tools and we'll be installing Torch Vision and Torch Audio, as well as transformers, accelerate and other packages that's needed for this whole thing. Moving on, I'll expose other things as well. Like I'll be exposing the ports on which we'll be serving our Triton server. And I'll set up an entry point so that instead of calling the command Triton server, we could just run this Docker and it will start with this only. So on the server, the Triton server is located in opt, and we'll be using the binary file Triton server. We'll provide another argument, which is model repository, which will be equal to models. So yeah, we are done with this. We can create image uh, on this using Docker build -t. We'll name our Docker file to be, let's say VLM, this VLM, and using current directories Docker file. So in this way, you can build your image. I've already built it initially. So Docker images, you can see that it's already been created. We'll use this. Next thing is setting up our VLM on Triton server. So you see, there's certain requirements like Triton looks for the whole, as you could see, in the entry point, we provided models, and Triton Server expects the directory to look something like this, the working directory and the models folder, which in this case it's one, and a config file which will contain how our input or output would look like, and the one model defining the one deep learning model that we'll be using. Mostly people use Onyx runtime, which is better. Sometimes PyTorch model you can also use, or TensorRT or TensorFlow, but we'll be creating a different whole model PY because let's say if we have to include some other logics to handle input or output, the script would help with the execution. So in this case, our working directory is tutorial itself. I'll create the another directory named VLM, and inside it I'll create one folder. We have our VLM folder with one. I'll add my config pb.txt. So here it is. Config pb.txt would include how what exactly our model name is. Let's say we are defining a model name as VLM. Another thing is max batch size. You can set it to 1 to anything you want. If you have batch processing, I'm setting it to 0 for just in case. Now I'll define my input, which would look like this. Since we are providing text and images input, I need to provide two kind of input. We'll be calling it through our script by name. So I'll set its name as text input for our text. Its data type, which would be type string. And as for the dimension, let's say I want to give multiple text like multiple text length batches. could just work like this. Basically, this is text size, number of characters. Next, we'll be similarly adding for our image. I'll just change the name over here from text to image. Another thing, the output that we'll be expecting from the server. This can also be written as the same way it is. I'll just change its input to output so that it's easy to identify in the system. I'll save this. Moving on, we'll create a model py file, which is this. I'll import basic packages that we'll be using in the script. Import torch, import numpy. From IO, import bytes IO. From transformers, import auto model for causal LM. Yeah, pretty much that's it. I'll also import one more thing, which is not installed exactly, but it's a kind of a file that will be in our Triton server. It will, since the Triton server will execute this from from the container, it will be able to access it. Right now, it's not my access. So this is the one, Triton Python backend utils. Next is I'm importing OS. So there's this thing that every time you create an image, some error happened. You need to the transformer module will if it not cache the weights, it will re-download it. So I'll be using a downloaded Triton weights and mount it on my Docker container so that it could use directly from there. For that, I'll set up a model path, which will be OS environment. I'll provide it the model path through the environment variables while running my command. In case if you want to use your own model, you can just specify its name. I'm using OS24B. Right. So moving on. So when we'll be using Triton server to run this py file, it will look for a class named Triton Python model. It will create an object inside itself and use it to serve our VLM. So in this Triton Python model, there's two things that needs to be there for our Triton server to identify which function to execute. One is initialize, and another one is execute so that it could handle the request that we are sending. Right, let's start with initialization. It's similar to a init constructor of a class, but as what Triton says, we need to do it like this. So I'll first define our device. I have a 4090, RTX 4090 with 24 GB VRAM. So I'll be using torch device CUDA. In case you don't have CUDA, you want to use CPUs. I'll add this one just in case. Next, we'll load our model, self.model, which will be auto model for causal, the static method from pre-trained, providing the name of the model or path to it, providing torch D type, which is torch load 16. There's one more argument that we need to provide since it's a multi-model. We need to provide this. I'll set it to 32768. These arguments are mostly from the OS2B tutorial. It's code snippet. You can find it online. Plus remote code. So my pre-trained weight, along with my pre-trained weights, there will be other modules, Python modules that we'll be using for the processing. I'll load this to my device. Pass it to my device. Sorry. So there are other things that I need for like handling input and output. One is visual tokenizer, which is inside cell.model. Get visual tokenizer, similarly for text as well. Yeah, we are done with the initialization part. Let's start with execute. Since we'll be sending multiple requests, we can send multiple requests. So we need to send multiple responses also. And for each request, we need to iterate. We'll handle the input that we got from our client into the server by getting it from using pb utils, get tensor by name, get input tensor by name, sorry. In this case, it's a request from where we want it. And the name of that kind of input is text input, as you could see from the config, text input. Similarly, we'll set the as numpy, convert it into numpy, use it first value, and decode it to UTF-8, since this is bytes. We can do the same for image P64. We'll just copy this. Same, we'll just need to change it to image. Next is for the model to work, like to give it to visual tokenizer or the model processor, we need to convert this string into an image. So decode image, which in this case would look like images image dot open. Oh, sorry, I did forget to put this. Compile import image. I'll send this a bytes file. Base 64 B64 decode image 64. Yeah, our image is decoded. Now we'll process the inputs, pre-process the inputs for our model processing. I need to convert this into prompt input IDs and pixel values. I'll use models method to reprocess the inputs, where I'll send in this format. This is again from the OS24B tutorial or the code snippet. I'll send the images as list and set the max partition to 9. Oh, we have image. Now, attention mask, we also need to provide, which will be torch.any, which has same dimension as our input IDs. And we'll use self text tokenizer paired token ID. Correct. This will be a single sequence, not a batch. So we need to convert it into a batch for the model to handle it easily. And we'll cast it to the device, self device. Similarly, we also need to convert cast our input IDs to our device. And this is also actually in singular line. We need to convert it into a batch. It should be in squeeze 0. Moving on, we need to do the same with pixel values. Pixel values to device, self.device. It's deep type to torch. Not that. It should be self.visual tokenizer.d type. Yeah, pretty much that's it. Let's infer it using torch inference mode. We get our output IDs, which will be self.model.generate. Function to generate, we'll provide our input IDs, pixel values as pixel value itself. Next, attention mask, which is same as attention mask. We'll only expect new tokens to be of length 1024. That's not to generate too much tokens. Do sample false. We'll just give it the end of statement token ID, which is self.model.generation config EOS token ID. Same for the pad token ID. Self.text tokenizer.pad token ID. Yeah, this will generate. We'll need the first batch value. This will be a singleton output. We'll decode it. We'll decode the output IDs to output text using self text tokenizer decode provided with the output IDs, and we'll skip these special tokens, the EOS, BOS, and any other token that is used for this. Yeah, so we have our output text now. We'll create a payload output tensor, which is pvutils.tensor, pass it as tensor. Name will be text output for our server for our client to identify, and for the server to send. I'll be sending it as np array containing our output text. I'll encode it and send it as type numpy bytes. Correct. Moving on, I'll add it in my responses, which would look like pvutils.inference response will contain output tensors as out tensor. Perfect. We are done with our responses. We'll just return it, and we are good to go. Our config is done. Model py is done. I'll just check it for some error. And the one error is only this one. It will be handled in the Triton server itself. Let's run our thing. So the command that is for this is docker run. I'll give all my GPUs to it, whereas I have only one. Start the machine. I'll provide the exposed code that we'll be using, that we have exposed. Exposed 8000, sorry. I'm sorry. Right. That issue dash p 8001 to 8001 dash p to 8002 to 8002. Similarly, I'll provide the environment variable where I have downloaded. Oh, I sorry, I forgot to add this. Forgot to download my HuggingFace. Just I'll use this. I've downloaded it into my GitHub OS2B 24B. I've downloaded my OS2B 4B pre-trained weights into this folder, and I've switched off the symlinks so that it would so that the container doesn't need to look at the symlinks, but it can directly access the whole file. And if on running this, my models will be downloaded. I've already cached the download, so it won't take much time. But in many cases, like if this is a 10 GB file based on your speed, it will take some time. So in this model path, as you know from our Docker file, we'll provide it the path. We'll just give it the path VLM OS2 for the. This is not our path. Actually, this was just a variable which will mount in our container. And similarly, uh, for the mounting of that, I'll just provide it the address tech desktop GitHub HF and OS2 for B. It will mount to the environment variable that we provided, which is OS2-OB. And we'll for our Triton server, I also need to provide it the current working directory, the model repository, as I told you from here, as our models folder, since this is the command that was in the entry point. And we'll start it. So our server name was Docker images that I've already created with everything. It is VLM. I'll just run this up, VLM. So yeah, it's loading. Okay, some error happened. Let's check what happened. Failed to load VLM. Just collapse this. Environment is not type error. Environment object is not callable. Okay. On which line this is happening? 6. Is not callable. Model py 10th line. Where is our 10th line? Okay, environment should be get env actually. Right. Sorry for that. Let's just read on a command. Setting it up. Everything going smooth. It has been initialized, as you could see, loading checkpoints, and it's now serving on our HTTP server this, whereas gRPC is 8001. We can directly try our model. Let's just fire up a Python notebook. I'll do the honors. So actually, you need to install this. You can use request and directly request to the client, but it's better in this way. Right, and client all. I've already installed it, so I'm not going to run it. I'll import it, import Triton client HTTP as HTTP client. I'll import NumPy for the payload. I'll import base64 to encode image, downloaded image. I'll use temp file to download the image inside a temporary file. I'll use your lib request to download this. We're done. Let's first provide the download function URL. I'll use temp file, temporary name temporary file. I'll make sure it doesn't get deleted immediately. I'll set the suffix to png as temp file. I'll download the URL request retrieve URL retrieve, provided the URL and temp file name. Just for good things, if image is downloaded, we'll just log it and we'll return the temp file name. It will basically contain our path as well. Another function is to encode image. Encode image will be using image path. I'll open it with open image path, feed it as binary. I'll return a base64 encode. Yeah, I'll use it as read the files in it, decode it to UTF-8, so that it will be a red string. Yeah, we are done with the functions. Moving on. So let's just download the image. In this case, I'm using the image from the OS 2B spaces. Show you what that is. So this is the link to the image that I'm using. The equation for the GRPO. We'll be trying to extract text and equations from it. So we'll provide the URL of the image to be this and download it. Image path to download URL and image B64 encode it through encode image path. Yeah, it's downloaded. We have our image input. Similarly, we'll set our text. We'll give it a prompt. Let's say extract text from the image and format any equation, any extracted equation actually. Equation as markdown equations or latex. Yeah, these are inputs, images downloaded. The next thing is we need to create a payload. Next thing is creating connecting to our client actually, which is HTTP client inference server client. You can use async if you have a asynchronous job that you want to run on your deployments. Since we are connected to the local host and forwarded it to the 8000 port, we're using this. Our client is set up. Now creating the payload, which is for text input. I'll be using HTTP client for input. The one that we are using in text input, as you remember from config, PV text. I'll set it size to 1 and set its format to bytes in server and store it. Text input set data from numpy. It's numpy array containing text with d type and p bytes. We'll do the same for the vision. For the image, I'll just use this image, right, and also convert it into image base 64. Our payload is done. I'll run this. No error happen. Now, like infer it. So we will get the response from the client dot infer. Since the model name is VLM that we have served on the server, inputs would be text input and image input, right? Right. And the output that we are expecting will be in the response. We'll run this, take some time. This model is big. We got a response. We'll extract the output from the response as numpy. Its name is text output that we are expecting. We want its first element, decode it, and let's just print the output. So yeah, this is the pretty much the equation. Let's try to look how much it matches. I'll just render it into a markdown file. Okay, there has been some generated issues over here, but let's just match it up with our image. Let's download it. The image path actually. Okay, it's temp file. I'll open it. Image.open. Okay, I haven't imported pill from pill import image. Okay, I'll just collapse this up, make it smaller. As you could see, for each question's queue, GRPO samples, most of the strings are correct. Pi theta volt, this should have been a subscript. No worries. Model pi theta, it was unable to render this equation, I believe, as well as this equation, whereas this equation is perfectly created. So yeah, this is our tutorial to serving a VLM through our Triton and setting up the Triton server another way. I hope I helped you with setting up your Triton server.